Hello students, welcome to IMS Academy GATE Foundation course on Network Theory subject. So in this particular session we are going to discuss regarding the basic class second session. In the last class we have discussed regarding the basic class. So we started with the KCL, right? We have discussed the introduction part and we have discussed in detail about the KCL. In this particular session we will be continuing further based on KCL. We will be discussing variety of GATE questions, right? So this particular session is common for three branches: EC, electrical and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session, right? So before going to start today's session, so all of you like and share this video link with all of your friends, okay? And whoever visiting our YouTube channel very first time, so all of you kindly subscribe our YouTube channel and then click on the bell icon so that you'll be getting instant notifications whenever the upcoming live sessions are happening, okay? Whatever the videos you are getting in our YouTube channel, you'll be getting all the updates if you click on the bell icon, right? So before starting today's session, I'm going to give two important updates. The first update is regarding our Telegram channel, IMS GATE Academy Telegram channel. So regarding this particular link already provided in the description of this particular video, whoever not yet joined till now, so all of you kindly join our Telegram channel. It is free for everyone, okay? So say for example, currently the live session is happening, okay, regarding network theory subject, regarding the foundation course, right? So similarly, whenever the upcoming live sessions happening at our IMS GATE Academy YouTube channel, whatever the faculties might be writing during the class on the digital board, this particular notes we will be sharing in the PDF form, okay? That particular PDF we will be sharing in this particular Telegram channel, right? And you will be getting all the important updates whenever the upcoming live sessions are happening. You will be getting that updates also in this particular Telegram channel, and you will be getting all the important updates whenever we are conducting the seminar or webinar, okay? And in addition to that, you will be getting even government job notification updates also you will be getting, okay? All these updates you will be getting in our Telegram channel. And one more important thing, on daily basis our faculties will post one quiz question per day, right? So you people can actually participate. Yeah, good afternoon Matan. Yeah, so all of you can actually participate in this quiz question. So you can attempt whichever option you feel correct among the given choices, and after you are attempting, you will come to know whether your answer is correct or not, okay? The very next day our faculty will provide the solution for that quiz question. Suppose by mistakenly or either intentionally or unintentionally, suppose somehow there you got wrong answer, okay? So you can cross check from the explanation or solution provided by our faculty. From there you can correct it where you have done the mistake, okay? So in this way you are getting great opportunity. On daily basis you are learning one quiz question, okay? So all these features you are getting for free of cost. Whoever not yet joined till now, kindly join our Telegram channel. So all of you kindly share this valuable information with all of your friends and juniors, okay? And one more important update, so that is regarding live online program that we are offering at our IMS GATE Academy for the aspirants whoever targeting for GATE 25 or 26, right? So whoever interested to enroll for these live online programs, right? So you people can contact to any of these two numbers. Our counselors will discuss in detail about the program features. Yeah, Amarjit. So since this is the basic foundation course, so I am just covering the basic concepts of the first chapter only, okay? So regarding transients and two-port networks, that I am not covering in this particular foundation course. But in future, when we are conducting various series, okay, so in that upcoming series, then definitely we may be covering the questions wise regarding those concepts, okay, right? So currently I am discussing the features of this live online program, right? So whoever enrolling for live online program, all the students are getting 800 plus hours of live online classes, okay? So you will be getting, for every subject you will be getting the theory book, exercise book, okay? In the exercise book we are having 3 levels of questions like level 1, level 2 and level 3. Together you will be having, so all the, with respect to your branch, okay, when you consider all the exercise book questions, you will be having 4000 plus practice questions, right? So whoever attending our live online classes, here during the live online classes, our faculties will discuss each and every concept from the basic level to the application level. Okay. Yeah. So whoever, like, some of you are mentioning that, sir, I want this topic or I want that topic, etc. Actually, transients is a very important topic for network theory subject. Generally, most of the students will face the difficulty while solving the transient questions and all. So whoever want to get very good rank in the upcoming years, like 25, 26, right? Okay, so you people can enroll for the live online program, because whoever enrolling at our live online program, they are getting all these benefits, right? So you can get the maximum knowledge, whatever required, whatever the preparation you are supposed to do for your coming GATE exam, that most of the preparation is getting over during the classes. And in addition to that, while you are solving the exercise book questions, while you are solving the GATE question bank, etc., whatever the remaining preparation is there, that is getting completed with the help of exercise book and GATE question bank, and even with the help of test series as well, right? So in this way, you are getting the revision and practice. Okay, whatever the resources required for your coming GATE exam, here at our IMS GATE Academy, we are providing each and everything, right? So whoever interested, so kindly contact to any of these two numbers, and our counselors will discuss more about our live online program which we are offering at our institute. Okay. So in the last class, I have just introduced the regarding KCL, and then regarding whatever the basic conclusion points are there regarding KCL that we have studied, and then we have discussed some questions, and I have given one GATE question as a homework. Okay, how many of you tried that question? So I will show that question. So this is the question I have given as a homework in the last class. So whoever tried this question earlier, so you people can mention your answer in the chat. Whoever visiting or whoever watching this particular question very first time, okay, no issue at all. Now I am giving some time for everyone. All of you kindly try. And whatever the answer you feel correct among the given 4 choices, you can mention in the chat. Matan and other students, please confirm regarding audio, is it clear or not? Yeah, I think it's clear. So Amarjit, you can cross check, you can increase your volume in the mobile or laptop from where you are watching. This is a very interesting question based on KCL. All of you give a try, whatever the given data is there. So consider that given data and try to identify among the given 4 choices which one is correct. Yeah, time up. Yeah, now let us solve this question. See, earlier also in the last class, we have solved one question based on KCL, right? So similarly, this question is also based on KCL only, based on KCL. Yeah, Amarjit, you can cross check once. Okay. Yeah, no issue. You have well tried. Okay. Now, whatever the explanation I am telling, okay, you just focus from there. Okay. You may get one other option. Okay. Right. So, here in this question, you are having 3 resistors. Okay. All the resistor value they have mentioned as 1 ohm resistor. 1 ohm resistor. Okay. Yes, very good, Amarjit. Very good. Excellent. So here they have given current values, I1 equal to 2 ampere, I4 equal to minus 1 ampere. Okay, what are the given data is there, you can represent. Here I1 equal to 2 ampere, I1 equal to 2 ampere, okay, and I4 equal to minus 1 ampere. So here you can observe, I4 direction they have given like this, but the value of the I4 is negative. That means in the opposite direction, 1 ampere current is flowing. See, in this direction, if minus 1 ampere is flowing, in the opposite way, plus 1 ampere is flowing. Okay, right. So they have given information with respect to I1 and then I4. Okay, and I5 also they have given, that is minus 4 ampere. I5 equal to minus 4 ampere. So here I5 direction is downward. Okay, so if you want to convert, since it is a negative value, I want to represent as positive. So that means in the opposite direction, 4 ampere current is flowing. Okay, in this way, whatever the given currents are there, that I have represented. Okay, right. Now you can apply KCL. Say for example here, okay, you can start from this particular node. Okay, to this particular node, total 3 branches are connected. Okay, out of which 2 branch currents you know, so you can calculate another branch current, right? So here you can observe 2 ampere current is coming here, out of which 1 ampere current is leaving. That means obviously in other branch 1 ampere should leave from this particular node. That's all. Here 2 ampere is entering and together 2 ampere is leaving. Okay, so that means here in this branch to this particular node, 1 ampere is coming. Okay, and whereas here 4 ampere is leaving. That means in this branch actually 3 amperes should enter. See, now you can apply KCL. In these 2 branches together 4 ampere is coming, the entire 4 ampere is leaving from this particular node like this. Okay, right. So up to here what you got, in this branch 3 ampere current is flowing. That means I3 value is what? I3 is opposite to that of this direction. Actually 3 ampere is flowing like this, I3 is flowing in the opposite way. So that means I3 equal to minus 3 ampere. But here in option B, they have given I3 equal to minus 4 ampere. So that is wrong. Okay. Here actually we are getting I3 minus 3 ampere, but they have given minus 4 ampere. Okay. Right. Now, okay, this I have retained because you are having one of the choice regarding I3. Okay. Now you can apply KCL once again at this particular node. Okay, in this branch 2 ampere current is leaving from this particular node, and similarly in this branch 3 ampere current is leaving. So if you carefully observe from this node, in these 2 branches together 5 ampere current is leaving. 2 plus 3, 5 ampere current is leaving. That means here in this branch 5 ampere current should enter. That's all. 5 ampere current should enter, right? So if 5 ampere is coming, together 5 ampere is leaving. So since 5 ampere direction and I6 direction both are same, so that means I6 value equal to 5 ampere. Yes, option A is correct. Actually this question they have given in the EC 2014 year. That time this question is MCQ. Okay, but nowadays since you are having MSQ type of questions, okay, so they can give like in one of the choice, like I6 equal to 5 ampere, similarly I3 equal to minus 3 ampere if they have given, then you can choose both are the correct options like that. Okay, so like these questions they are having the scope of MSQ. So in this way, whenever you are solving any of the previous year's GATE question, okay, first and foremost thing is, as per the given data, what they are asking to calculate that much. But after that, if you are having some extra time, you can contemplate the given question and whether since they have given that question is MCQ, whether is there any scope of MSQ, etc., or is there any other parameter they can ask to calculate, etc., then from there you will be getting ideas. Try to solve those kind of questions in that way. At least I am not saying that all the questions you have to solve like that, but instead of all the questions, at least for selected questions, if you are doing like that, then whatever one question is there, with the help of that you are getting n number of models or n number of problems you can frame like that, or n variety of questions based on the same circuit. Okay, so in that way you are getting, for practicing good number of questions, with the help of limited questions you are making good number of practice questions. If you are doing like that, then you can, like, whatever the preparation you are doing or whatever the practice you are doing regarding network theory subject, in fact whatever the learning you are getting, okay, while you are learning the subject, in fact you can enjoy a lot, and that is the right way of preparation. If you are doing like that, okay, whatever may be the type of the question, let them give in the GATE exam, you people can easily attempt, okay, and in fact you can get the correct answer. Okay, right. So here option C, since option A is correct, obviously we can eliminate C and D. Okay, C and D are not correct, because in this question we can calculate I3 value, we can calculate I6. Luckily here I6 is matching. Okay, whatever they have given in option A, that value is matching here. That's why option A is correct. Okay, right. So with this understanding, now I am showing the next question. So this is also GATE question. So in this particular session, we are going to discuss the variety of questions which are asked in the GATE exam based on KCL. All of you give it a try. Amarjit, you can cross check once regarding the direction or polarities. Just cross check once. So this is a very interesting question. When you look at the question, okay, when you look at the circuit diagram, here you're having number of resistors, and they have connected, like, series, parallel, and then between the two nodes they have connected. It is like very big circuit or complicated circuit in one sense. When you look at the circuit diagram, you might have thought it is a very tough question to solve, but whatever the information regarding this particular circuit, whatever the information they have given, if you are catching that given data, and if you are using, just like in the earlier question, they have given the data with respect to currents. With respect to currents, they have given the data. So directly we have represented that given data, and based on that we have applied the KCL. Similarly, Similarly, whenever you feel the circuit is very complex, or it is very time consuming, okay, for given question, in order to solve it is more time consuming, at that point of time, okay, instead of contemplating too much about the circuit, better whatever the given data is there, okay, just consider that data and utilize that data in the given circuit. From there you are getting the clue. If you are getting that clue, then after that you can solve these kind of questions just like that. It won't take much time. Okay, so just observe here. Here in this question they have given VA minus VB equal to 6 volt. Okay, so here you can observe VA is the node voltage. Here you are having 2 ohm resistor, right? 2 ohm resistor you are having, it is having 2 terminals, right? One side the node voltage with respect to ground is VA, another terminal the node voltage with respect to ground is VB. So between a resistor, between the 2 terminals of resistor, the whatever the node voltage you are having, okay, the difference between those 2 node voltages is nothing but what? The voltage across this particular 2 ohm resistor. Okay, voltage across 2 ohm resistor is nothing but VA minus VB. VA minus VB. Okay, so in this particular question they have given VA minus VB is 6 volt. VA minus VB 6 volt. Now you are having 2 ohm resistor. Across the 2 ohm resistor you know the voltage. Once if you know the voltage and once if you know the resistor value, can we calculate the current? Yes, obviously we can calculate the current by using Ohm's law. Since you are having plus sign here and then minus sign here, the current in the 2 ohm resistor is flowing from the terminal A to B. Okay, because whenever you are having resistor, current always will flow from high potential to the low potential, or plus sign to the minus sign, like that. Okay, so 6 volt you are having 2 ohm resistor. By using Ohm's law you are getting 3 ampere. So in this 2 ohm resistor 3 ampere current is flowing. 3 ampere current is flowing. Okay, now the question is what? Here you have to calculate VC minus VD. VC minus VD. Okay, so whatever the given information is there, with the help of that we are getting in this 2 ohm resistor 3 ampere current is flowing like this, and in this question we have to calculate VC minus VD. Now once if you understood this much, now whatever the circuit here you are having, okay, say for example here whatever the circuit you are having, this entire circuit, okay, whatever the combination of resistors and then voltage source, whatever you are having, this entire combination you can consider like one network. Okay, I am assuming that one network B. Okay, so for this entire network, you can observe, for this entire network, okay, you can observe with the help of this resistor, 3 ampere current is entering. 3 ampere current is entering to this particular network. Okay, see earlier we have discussed KCL with respect to a node. Okay, the same KCL even we can apply to a particular network also. So whenever you are having a particular network, okay, for that network how much current is entering, that much current should leave through other terminal. Okay, say for example when you have considered this one network, okay, here the current is entering, okay, whatever the current entering here towards this particular network, that same amount of current should leave from this particular network. Okay, so that means here 3 ampere is entering, the same 3 ampere is leaving from this particular terminal or network, we can say. Is it clear? Yes, very good Amarjit, very good, excellent. Similarly here, whatever this entire section you are having, this entire section if you want you can consider like network A. Okay, say for example from this network in this branch 3 ampere current is leaving, right? So since here 3 ampere is leaving, okay, the same current 3 ampere should enter. Okay, so for any given network, how much current is entering, the entire current should leave through other branch, like that. Okay, so that means here the conclusion point is KCL is applicable with respect to a node, even KCL will applicable with respect to the network also, right? So just like you can consider like one house. Okay, so for any house, how much current is entering together, that entire current should leave through other terminal, like that. No, circuit is not wrong. Okay, KCL we can apply for the node also, KCL we can apply for the network also. Okay, right. Because whatever here I have discussed, okay, just for easy understanding, say for example here you are having, okay, instead of this much network, okay, if you are having simply resistor, say for example, okay, just for easy understanding I am considering like this. Suppose here you are having terminal 1, terminal 2, terminal 1, terminal 2, okay, between 1 and 2 you are having one resistor, suppose. Okay, suppose the current I is flowing like this, then obviously the polarities you will be getting plus here and minus here. Okay, the voltage across terminal 1 and 2 will be V for the timing. Whatever the configuration here you are having, okay, that entire configuration for the timing I am representing like this. Terminal 1, terminal 2. Okay, so here the resistor R, whatever the current entering here, same I am representing, because current I enters here, plus minus here. Voltage across it is V. Now you can consider whatever the resistor you are having, resistor is having two terminals, right? So whatever the resistor here you are having, that resistor, since you are having two terminals, okay, now if you were representing as a dashed line, okay, now it is having what? Two terminals. Any two terminal network we will call it as port. Okay, so this one we can call it as port. So like that, if you are having two such ports, then we are calling it as two port network, like that. Okay, so here for the easy understanding I have considered one resistor, so that resistor is having two terminals. In the similar way, instead of resistor you can have like this circuit or network, whatever it may be. For any network you will be having two terminals. Okay, with the help of one terminal, okay, whatever the current is entering to that network, the same current should leave. You can observe here, I current is entering, I current is coming to this particular node, right? So here I current is coming like this, and the same current I is coming like this. That means from terminal 1 if current leaves to the terminal 2, the same current is entering, like that. Okay, so with this understanding, now I hope all of you got the clarity how we can apply KCL to a particular network. Okay, now with this understanding, now you can observe here at this particular node, now I am applying KCL. You can observe here in this branch 2 ampere current is coming, and in this branch 3 ampere current is coming. So in both the branches the current is entering to that particular node. That means resultant current is 5 ampere. That entire 5 ampere should leave from this particular node. Okay, so that means here 5 ampere is going like this. So here 5 ampere is coming like this. Okay, so if you want you can represent the same current like this. Whatever the current is coming, the entire current is going like this. Now since current is entering like this, that means here you're having plus sign and here you're having minus sign. Just you can use Ohm's law, that's all. Current you know 5 ampere, and you know the resistor 5 into 1, that is nothing but 5 volts. Earlier case, because you're having 6 volt here and the plus sign minus sign here, the current is flowing like this. Okay, but here in this case 5 ampere is coming from right to left, that's why here plus sign and here minus sign, that's all. Okay, so in this question, yes, very good Amarjit, very good. Okay, so here in this question they are asking VC minus VD. Okay, so here you are having resistor, here you are having current source, they are connected in parallel. Obviously in parallel voltage will be same, right? So the voltage across 1 ohm resistor, voltage across this current source, both are same. Okay, that is nothing but here VC minus VD, just like here VA minus VB. In a similar way, VC minus VD. So here actually if you observe in this question, VD is having plus sign, VC is having minus. Okay, so here I am writing VD minus VC equal to 5 volt. So from here, because they have asked VC minus VD, just take minus as common. If you take minus as common, then you are getting VC minus VD, that is equal to 5 volt. So from here you are getting Vc minus Vd equal to minus 5 volt. This is a very interesting question because you have to take care about the sign also. Okay. So here the final answer for this question is option A. Option A is the correct one. See, in the previous question they have given the information with respect to currents. Okay, even the resistor value they have given, but since they have given directly current values, we have applied the KCL at the nodes and then we have solved. And this question, okay, in majority of the resistor values they have mentioned R, but this resistor and this resistor they have given the value. Okay, and surprisingly they have given, instead of current they have given the voltage difference. With the help of that and by using Ohm's law, we calculate the current and once again we have used the KCL. That's all. Okay. So whenever you are getting like this complex circuits, okay, just visualize whatever the part of the circuit you are having can we consider like this two-port network, like this one network. Okay, one network which is having two terminals. That means one port network. Okay, so this one network, this one more network. Okay, I hope all of you got the clarity. So with this understanding, now let us move on to the next question. All of you give it a try. Yes, very good Amarjit, very good. So just mention your branch and currently in which year BTech you are studying. Very good. Option A is the correct one. See, in this question, and just correlate. See, whatever the circuit here you are having, okay, like this circuit only. This entire thing earlier I have considered like one network. This is one more network, right? So like that they have considered here network N1, network N2. Okay, between these two networks they have connected two resistors and one voltage source, right? So whatever the logic earlier we have discussed, okay, you can apply KCL with respect to this network. Earlier while solving this question I have applied KCL with respect to this network, right? Similarly, if you want you can consider KCL with respect to this network, even you will be getting the final answer will remain same. Yes, very good. You are from electrical third year. Yeah. So here, see, since you are having voltage and resistor, once again by using Ohm's law we can calculate the current. So since you are having plus sign here, that means the current is flowing like this. Okay, so 6 volt divided by 3 ohm, that means 2 ampere. 6 by 3, that is nothing but 2 ampere. Whereas here the plus sign is present here. Okay, so that means the current is flowing like this. That's all. Whenever you are having resistor, if they have given voltage polarities, wherever plus sign is there and plus 2 minus, the current is flowing, that's all. Okay, in that direction the current is flowing. Here 2 by 2, that means 1 ampere. Now if you want, you can apply KCL with respect to this network, or if you want, you can apply KCL with respect to this network. Okay, with the help of any of the two, you will be getting the same answer. Okay, for solving the given question, you can apply KCL here or KCL here. Okay, so for the timing, I am applying KCL here. You can observe 2 ampere current is coming to this network. Okay, out of which 1 ampere is leaving. That means obviously here in this branch, 1 more ampere should leave. So that what will happen? 2 ampere is coming, 2 ampere together is leaving. That means whatever the current is coming to this particular network, the entire current is getting leaving from that network. That's all. Okay, similarly, if you want, you can apply KCL with respect to this network. Here in these two branches, together 2 ampere is coming or entering, the entire 2 ampere is leaving, like that. Okay, right. So now the question is what? Now the question is, here they are asking the power delivered by 5 volt source. Okay, here you are having 5 volt source. How much power delivered by this source? That is the question. Okay, so here you can observe, here current enters at negative terminal. See the difference between with respect to the passive element and with respect to active element. Here whenever you are having passive element, the current enters at positive terminal, that means it is absorbing the power. Similarly, suppose in the given circuit, see in this question you are having only one source. Okay, so here the current enters negative terminal. Suppose if you are having more than one source, okay, present like this. Okay, suppose in that case, even in this particular example also, suppose somehow that if they have given plus sign here and minus sign here, okay, whatever the convention here you are having, current enters at positive terminal, current enters at positive terminal. Similarly here also, if positive terminal present here, since current enters positive terminal, that means actually this source is not delivering, rather it is absorbing the power. But in this question, since you are having current enters at negative terminal, that means it is delivering the power. Okay, in this way we have solved some good number of questions in the earlier class. So whoever not having the knowledge whether with respect to sources, okay, because the term source is there like voltage source or current source, then definitely most of the students are having the misconception that source means it is always delivering the power. Whenever one source is present in the given circuit, definitely it will deliver. But when more than one source present, or especially in between two networks, when even when single source is there, okay, that source or some of the sources can deliver the power, some of the sources can absorb the power. Whether the source is delivering or absorbing based on the sign convention, that concept even we have covered in the earlier class. So whoever missed that concept, you people can refer, you will be getting the clarity of understanding regarding that particular concept, because that is the most important. Because in some questions, just like this question, they can ask whether the source is delivering or absorbing. Irrespective of that, they can ask any parameter, how much power is delivered or how much power is absorbed. Okay, in this question there is no confusion at all, because current enters negative terminal, that means it is delivering the power. Okay, so here power is nothing but, so power delivered by 5 volt source. So here power is nothing but voltage into current. Power is nothing but voltage into current. Here you are having supply voltage is 5 volt. You are having 5 volt and the current flowing here, it is 1 ampere. So 5 into 1, that is nothing but 5 watt. Since current enters at negative terminal, whatever the power just now you calculated, so this power is nothing but delivered power. This power is nothing but delivered power. Suppose the same question, if they ask instead of delivered power, if they ask how much power absorbed by this particular 5 volt source, since you got delivered power is positive, absorbed power will be negative, that's all. Yes, very good, Amarjit. Absorbed power, if they ask, it will be minus 5 watt. Just like earlier I have told, if 2 ampere current is flowing like this, in the opposite way, minus 2 ampere is flowing. In a similar way, if the delivered power is positive, absorbed power will be negative. Or if the absorbed power is positive, delivered power will be negative, vice versa. So for this question, there is no confusion at all, because all the choices are having positive sign. But whenever you're having some choices like negative or positive, that time you have to take care about the sign. But this question, the moment you are getting like 5, so there is no confusion at all, because the moment you have calculated 1 ampere, 1 into 5, 5 watt, only one option is there regarding 5, so directly you can choose option A. But this knowledge is required, especially when you're having plus sign and minus sign, or even like NIT questions, that time you have to take care about the sign. Okay. Now all of you give a try. The next question, which is asked in GATE EE 2017, set 1 for 1 mark. All other students also please try, and whoever watching this particular session later, you people, after seeing the question, okay, before watching the explanation, try yourself, and whatever the answer you are getting, okay, you can mention in the comment section. And whoever watching live session now, so you people can try, and what is the answer you are getting, you can mention in the chart. Yes, very good, Amarjit. Excellent, excellent. So here, even though they're asking power related to power calculation, but once again you can solve this question based on KCL. First step is KCL. After that, if they're asking to calculate power, you can use the power formula, that is nothing but voltage and current. Just you have to multiply. That's all. Yeah. So just observe in this question, you are having like voltage source is there, resistor, and then here you are having current source. But this current source is what? Dependent current source. You can observe whenever you are having the symbol circle, that means it indicates independent source. Okay. Whenever you are having the diamond symbol, okay, or rhombus symbol, that indicates dependent source. Here you can observe, here you are having plus minus, that means polarities of voltage you are having, that is a voltage source. But here you are having arrow direction. Whenever arrow symbol is there, that indicates direction of current. That means it is a current source. It is a current source. But here this current source value depends on, here the current source value depends on some other current, right? So that means it is the current dependent current source. Current dependent current source. Yes, very good, Amarjit. Yeah. So here you can observe 0.4 anyway constant, but I is the current. So in this circuit, the current I is flowing in this particular resistor R1, right? Whatever the current here you are getting, that current we will substitute here and multiply with 0.4. Then that value is nothing but this current source value, like that. Okay, right. So just observe here at this particular node. Okay, so the current I is coming like this, and similarly here in this branch, 0.4 I current is entering. 0.4 I current is entering. Okay. To this particular node, once again 3 branches are connected, out of which in 2 branches the current is entering, right? So entering currents we can add. So I plus 0.4 I, that means I plus 0.4 I. Okay. Whatever the current together is coming to this particular node, the entire current is flowing like this. Or even you can observe here, they have given in this branch the current flowing is 14 ampere. 14 ampere. Okay. So 1 plus 0.4, that is 1.4 into I is equal to 14. So here 1.4, here 10 times. Okay, 1.4 into 10 is nothing but 14. Yes, very good Amarjit, very good. So from here you are getting current I equal to 10 ampere. Current I equal to 10 ampere, right? So here we calculated current value. Now read the question first. We have to calculate the power supplied. Power supplied or delivered, both are same. Okay, power supplied by 25 volt source. Okay, so since they have mentioned it is delivering, okay, so just like earlier we have mentioned, whenever you are having source, okay, if we want to say it is delivering, you can look with respect to negative terminal or you can look with respect to positive terminal. Say for example, here current enters at negative terminal or current leaves from positive terminal, both are same. Okay, so if current enters positive terminal, that means it is absorbing the power. If current leaves from positive terminal, that means it is delivering the power. Okay, just like for easy understanding, in general the water always will flow from high to low. Okay, but in the apartment or building, whatever the water present in the cellar, okay, so that water, how it is going to the on top of the 4th floor or 5th floor, okay, where we are keeping the tank. Okay, suppose you are having a building 4 floors, okay, on top of the 4th floor you are having the tank. From the ground floor to the top floor, how the water is going? With the help of which device or which instrument we are using? We are shifting the water or we are bringing the water from the ground floor to the top floor. How it is possible? With the help of motor, right? So in general the water will flow from high level to the low level, but if it is coming like reverse way, okay, so that means it is like with the help of motor we are able to bring the water from the ground level to the up level or top floor, like that. Okay, in a similar way, so regarding generator we can say as a source. Okay, so similarly here, whatever the source we are having, if we want to say it is delivering the power, so that means current should leave from positive terminal, right? So in a similar way you can observe here whatever the current we got, that is 10 ampere and that direction is like this. Okay, current 10 ampere is coming like this, that means here you are having the current direction in the same. Okay, you can observe here current leaves from positive terminal, that means it is delivering the power, it is delivering the power, right? So since they have asked power supplied, so that means here in this case power delivered by 25 volt source, okay, is nothing but voltage into current. Voltage is 25 and current is 10 ampere, so together you are getting 250 watt. So here it is the delivered power. Delivered power or supplied power, all are same. Delivered or supplied, all are same. Okay, right. So with this understanding, now let us move on to the next question. This is a question asked in GATE EE 2015 set 1 for 2 marks. So all of you try this question, and whatever the answer you are getting, you can mention in the chart. Okay, whoever still trying, you people can try. Okay, no issue. After you are solving, whatever the answer you are getting, you can mention the chart. Okay, first of all, try to understand what the given information. Okay, here in this question, you are having one circuit diagram, right? In the given circuit, the parameter K is positive. Where you are having K? Here you are having K. So this K value, they have mentioned it is the positive value. Positive value. Yeah, Amarjit, 0 is not the correct one. Okay, no issue. You have well tried. Okay, now you can focus. Okay, I will discuss. Okay, what value you are going to get for K. So here in this question, they have mentioned K value is positive. Okay, and here you can observe these two are independent sources. These two are independent sources, and this one is the dependent source. Okay, just like the previous question, you are having arrow symbol, that means it is a current source. Similarly here, arrow symbol, current source. But in the previous case, it is current dependent current source. 0.4 into I is current. It depends on other current. Okay, whereas here K into V naught, K anyway constant into V naught. V naught is what? Voltage. Okay, so that means it is a current source, but it depends on some other voltage. So that means it is voltage dependent current source. Okay, here in this circuit, V naught is present here. Across this 2 ohm resistor, whatever the voltage you are getting, that voltage you can consider. Okay, right. Now the question is what? Okay, let us continue further. The power dissipated in the 2 ohm resistor is 12.5 watt. Okay, here, yes, very good Amarjit, very good, excellent. Here you are having 2 ohm resistor. Okay, across the 2 ohm resistor, the amount of power dissipated is 12.5 watt they have given, right? So the power dissipated across the 2 ohm resistor, they have given 12.5 watt. So regarding power across the resistor, we have discussed 3 formulas in the earlier one of the session. So based on the given data and information, you can use any of the formula. Okay, so power is nothing but voltage into current, and V equal to I into R. When you have substituted like that, you will be getting I square R. Okay, R in place of I, when you are writing V by R, from there you are getting V square by R. Okay, since you are having V naught here, so now currently I am using that formula, power equal to V square by R. V square by R. So here in this case, voltage across the 2 ohm resistor is V naught, and the resistor value is 2, V square by R. From here you are getting 12.5. Okay, so do the cross multiplication. V naught square you are getting 2 into 12.5, that means 25. So from here you are getting V naught equal to 5 volts. V naught equal to 5 volts. Okay, yeah, yes, very good Amarjit. You can use I square R formula also, no problem. Okay, but here in this question, since they have mentioned here V naught, so accordingly I have used that formula, right? So as of now we are getting V naught equal to 5 volt. Okay, now the moment you got V naught equal to 5 volt, V naught equal to 5 volt. Okay, once again you can use, you know the voltage, you know the resistor. Can we calculate current? Yes, obviously. 5 divided by 2, that means 2.5 ampere. 2.5 ampere is coming like this. Okay, 2.5 ampere is coming to this particular node. 2.5 ampere is coming to this particular node. Okay, and if you observe, these two are connected in series. In series, obviously current will be same. So here 5 ampere is flowing like this. That means 5 ampere is coming from this particular node like this. Now with this understanding, you can observe 5 ampere is leaving. Okay, here 2.5 ampere is entering. Obviously in this branch 2.5 ampere should enter. So that resultant current 2.5 plus 2.5 together 5 ampere, that entire 5 ampere is going like this, right? So just like these two are in series, similarly 10 ohm and this current source, both are in series current will be same. So here 2.5 ampere is nothing but K into V naught, K into V naught. Okay, so from here I am writing K into V naught is equal to 2.5 ampere, and V naught just now we got 5 volt, you can substitute here. Okay, so here 5 K value is 0.5. Okay, I hope it is clear for everyone, right? So in this way, so if you observe what are the questions we have discussed in this particular session, right? All the questions based on KCL only. But in some questions with the help of only KCL equation, we are able to find out the unknown. But in some questions, they are combining the concept with the KCL and the power dissipation, either power dissipation or power delivered or power absorbed, etc. Okay, so accordingly, power is nothing but voltage into current with respect to sources. But with respect to resistor, when you are having, okay, so regarding the resistor, we are having 3 formulas. Based on the convenience, you can use any of the formula, right? So in this way, I hope all of you are getting the good clarity how to apply the KCL in the given questions in order to calculate whatever the unknowns we are supposed to calculate. Okay, so I hope all of you got good command how to apply the KCL, right? So we have solved variety of gate questions in this particular session based on KCL. Okay, so today we are having one more session at 4:30 p.m. Okay, 4:30 to 5:30 we are having 1 hour session. So in that particular session, I will be discussing regarding KVL. Okay, regarding KVL, I will be introducing, and then we will be discussing some interesting gate questions as well in that session. Okay, so we'll meet you all in that particular session. Today we are having one more session at 4:30 p.m. And once again, whatever the 2 important updates I have given earlier, so once again I'm showing those 2 important updates. Whoever not yet joined in our Telegram channel, so kindly join our Telegram channel. The link is provided in the description of this particular video. Okay, you can join in your free time. And one more update is regarding live online program at our IMS Gate Academy. Whoever like wanted to get very good rank in the upcoming gate exams, like in 25 or 26, you people can contact to any of these 2 numbers. Our counselors will discuss in detail about our live online program features, right? So you can get enrolled so that you will be getting maximum benefit. Okay, right? So all of you kindly share this valuable information with your friends and juniors, whoever wanted to prepare gate exam sincerely, right? Whoever want the proper guidance, etc. You people can share this valuable information so that whatever the doubts they might be having regarding this particular program, our counselors will clarify each and every student doubt. Okay, and after that, based on your interest, you can enroll for live online program, so that as I mentioned earlier, you will be getting whatever the preparation you are supposed to do for your upcoming gate exams, whatever the resources required. Okay, here at our IMS Gate Academy, we are providing each and everything. Okay, if you are investing your time, okay, for the right purpose, definitely you people can get, okay, you people will be getting happiness after seeing the result. Okay, it's up to you, whoever like want to enroll for our live online program, you people can decide, okay, after discussing what are the doubts you are having with our counselors, right? Yeah, so once again I am telling, like and share this video link with all of your friends, and please inform regarding the upcoming session. Today we are having one more session, right? Whoever visiting our YouTube channel very first time, so kindly subscribe and click on the bell icon so that you won't miss even single upcoming video, right? So thank you everyone. We'll meet you all on today at 4:30 p.m. for one more session we are having. So in that session we'll meet you all. Thank you. Thank you very much.